Hello and welcome. I'm Elizabeth, and with me today is my assistant, Joshua.
Hello there.
Now, Joshua and I are going to demonstrate how to shrink wrap a kid. Why would you want to shrink wrap a kid? Well, because you may want to have a very fascinating demonstration for students who are just about to study a unit or even a lesson on weather or air pressure. You might also want an engaging way to introduce your chemistry or physics students to, for example, the gas laws or even fluid mechanics, pressure, that sort of thing. So what you need to do this demonstration is a shop vac. It could be any kind of a vacuum. It could be your household vacuum. It could be a big old industrial vacuum. It just needs to have a hose. You also need a trash bag with a hole cut in it, and I've reinforced this with some cardboard. This is a lawn leaf bag, and you also need a kid. Ideally a volunteer, but perhaps not. I'm also going to make some pressure measurements while we do this demonstration, because this is a great way to quantify this demonstration. So what I've got is a dual pressure sensor, and I'm going to be collecting data inside the bag. Port 1 is set up to measure the pressure inside the bag. While on port 2, I have this long tube that's going to allow access to the external ambient air pressure, and the two will be measured simultaneously. I've also got an extension cable because this has to go and sit inside the bag with my assistant, Joshua. Are you ready, Joshua?
Yes.
Okay, take that and put it down into the bag with you. And you must not let it get sucked up by the vacuum when I put the hose in. I'm going to go put the hose in now, and you can help by making sure that the hose does not suck up any of your clothing or the trash bag. Now, I'm going to need to gather up the bag around his neck. I'm going to leave his head free, of course. And I need this tube to stick out of the bag so it has access to the air outside. So I'm going to kind of get that all situated. You doing okay, Joshua?
Yes.
And I'm going to hold this bag sort of gathered fairly tightly in place, but not too tight. I'm going to go ahead and start recording data on my graph here. And on my graph, I have two pressures displayed versus time. I have multiple y-axes with the pressure from port 1 on one axis and the pressure from port 2 on the other axis. So I'll go ahead and begin recording data. And I can notice that I'm hovering around atmospheric pressure in both cases here, about 101 kilopascals here in Roseville. Now, are you ready for me to turn on the vacuum?
Yes.
Let the shrink wrapping begin. Are you able to move very well right now?
No.
Not so much. Oh, my heavens. Now, can you tell us what that felt like to be shrink wrapped?
Like a big, big hug.
A big hug? How is that possible? You were in a trash bag the whole time, dude. Okay, let's look at our data. I'll stop recording and I'll let him de-shrink. We have two plots here, a red one and a blue one, and the red plot's showing the pressure outside the bag throughout the duration of the experiment. The blue plot is showing the pressure inside the bag, and we can see from the blue plot that there was a fairly clear drop in pressure during the shrink wrapping. The difference in pressure is about 5 kilopascals, about 5,000 pascals. So what's going on here? Well, inside the bag, the pressure was lower. Outside the bag, the pressure was greater. As I mentioned before, we're about at sea level, 101,000 pascals pressing down on every square meter, and Joshua's surface area is about a square meter. 101,000 kilopascals pressing in on him. Meanwhile, inside the bag, not as many kilopascals of pressure pressing back out. That's why it felt like a big old hug to my assistant, Joshua. And with that, we'd like to say thanks for joining us today. And remember that with Pasco, exciting science is in the bag.